Resistance and resistivity. We have already seen that if we apply same potential difference between the ends of geometrically similar rods of copper or glass or different material, very different currents are resulted in. This is actually due to, we have said that the current density is N multiplied by E multiplied by the derivative velocity. Okay? So N is a number of carriers per unit volume. The N per carriers per unit volume is different in copper from glass. So if we have a rod from copper and we apply electric potential, we will find the current density. If we have a same rod but from another material like glass, we will find completely different value of the current. The characteristic of conductor that enters here is the electrical resistance. So the difference between the copper and the glass and other materials is the electrical resistance. This electrical resistance, when varied from one material to another, the current due to a specific potential will be different from one material to the other. We determine the resistance between 2 points of a conductor by applying potential difference between those 2 points and measuring the current that results in. Means that if we have a rod and apply potential difference between the 2 terminals of the rod, this potential difference will introduce motion of charges. This motion of charge will introduce electric current. We will find out the relation between the potential difference and the electric current, and we will call V over I, the potential difference over the current, is the resistance of this rod. So the resistance R, which will be abbreviated R is the potential difference over the current following across the sample. So if we have a sample and apply a potential difference between the 2 ends of the sample, and I measure the current through the sample, V over I. The SI units of the resistance is volt per meter because it is potential per current. This volt per meter is called ohm and its symbol capital omega. So 1 ohm, which is 1 omega, is actually 1 volt per 1 ampere. Any conductor whose function in a circuit to provide specified resistance is called a resistor. So the element which its main function is to make a resistance is the resistor. So the resistor is the element. The resistance is the property of this element. The resistor is the element. The resistance is the property of this element. In circuit diagram, we represent the resistor and the resistance by symbol like this. It is simple line with zigzag line and simple line. And effectively, it starts with 1 up and ends with 1 down. Okay, so this is the symbol diagram of the resistor. We have said that the resistance or the resistor R equals the potential difference over the current. So in other words, we can say that the current equals the potential difference over the resistance. This means that the greater resistance, if I increase the resistance, the smaller the current. So increasing the value of the resistance will decrease the value of the current, assuming that the potential difference is the same. So The greater the resistance, the smaller the current. Now assume that we have two samples similar to each other, but we have applied the potential difference in different ways. One like this is an electrode, and we apply the potential difference through these two electrodes, and one with another type of electrodes and apply the same potential difference with the other type of electrodes. It can be quite clear from the current streams here is that the current streams in this case, which correspond to the current density, is less than the current stream in this case. So, although the two samples are the same, and the two samples are of the same material, and the potential difference between the two electrodes is the same, but the two types of electrode or the position of the two electrodes is different from case 1 to case 2 or from case A to case B. So the only difference here is the orientation of the electrodes or the orientation of the potential difference on the sample. This difference introduces difference in the total current here. So in this case, the resistance of this sample is different from the resistance of this sample. That's what we are seeing here. The resistance of a conductor depends on the manner in which the potential difference is applied to it. So we have a way to apply the potential difference in this sample and another way to apply the same potential in the same sample. So according to this method of applying the potential difference, we obtain a current greater than this method. So the resistance of a conductor depends on the manner in which the potential difference is applied to it. For example, the figure below shows a given potential difference applied into different ways to the same conductor. As the current density streamline suggests that the current in the two cases and hence the resistance will be different. So in this case, the resistance of this sample is different from the resistance of this sample, even so the two samples are of the same material and of the same dimension. But the orientation of applying the electric potential is different. Okay, so if it is different, how we can differentiate between the two samples in this case? It is required not to study the sample by itself, it is required to study the property of the material of the sample. And that's what we will see in the next video regarding to what we will see the resistivity of the material. Okay.